Yo, dog. So it's stream number 53. Today I think I'm ready, finally, to dive into a transport layer security. I'm going to be using the LibreSSL library today. And I only know a little bit about it, so I'm going to be like referring to some tutorials and just trying out function calls and see what happens. And I even got Wireshark installed actually yesterday to take a look at my attempt to do TLS. Wireshark will tell me if it's actually working or not. Some extra debugging. But first, some announcements. So, between now and last stream, I tried running stuff on Linux and Mac, found some errors and warnings. So, went and fixed those. Testing on Linux, I found a couple tests were either failing or getting stuck. And it was to do with how I was trying to do non-blocking sockets. Actually, it was on the Mac. I found that in Linux it worked, but on the Mac it didn't. And I'll show you what I kind of discovered. Okay, maybe it's easier to show you guys with a diff. So if I go to System Abstractions and I look at the history. So if I scroll this a little bit to the right, with functions like receive and send for a socket, there's this fourth argument, I think it's fourth argument, which is flags. On Linux, you can use this don't wait flag, which tells it to do a non-blocking call. Turns out that that's not available on the Mac. So I did the more traditional way to make a socket non-blocking, which is using fcntl. I guess that's file control. You can get the flags for a descriptor. So I got the flags for the socket. And then I turn on the O non-block. I guess that stands for option non-blocking. And then set those flags back onto the socket. So we do that right after connecting for a network connection. And on a network endpoint, similar thing. We want to set that after we have received a new connection. And also a third place for the socket for the server itself, where it's going to be listening. I think we're also, oh no, sorry, not that one. It's when we're using a server socket as a datagram or non-connection oriented socket. We use non-blocking mode. Otherwise, it works on Linux because of this don't wait thing. And Windows, we have WSA event select, which puts it into non-blocking mode anyway for us. But on the Mac, this would block unless we actually did this. So that's what I did. And it all seems to be working. Some of the things I had to use, I mean not use, but fix for compiler warnings. There were a lot of places where Clang, I guess, is used by Xcode on Mac. It would detect where I forgot to say no except when I gave the body of method like a destructor where it's declared as no except. It would basically say its specification for exceptions is not matching. So a lot of places I went and added that no except. And this, curiously, this construct here gets optimized away even in debugging mode or non-release mode. The compiler says something like it knows that there should be no effect to this or something. And it actually gave a suggestion in the warning in that because this is not a volatile location in memory or not declared as volatile, it has no effect. So I declare a pointer to a volatile integer, and then I just dereference that in order to purposefully cause an exception. There are a couple places in my tests where I want to do that to basically verify that something doesn't happen and don't have any other convenient way of detecting a side effect. So I create a big side effect, which is the test crashes. And in Google Test, there's a way you can check for that, which is called a death test. Okay, in a couple of places, this you get a warning from Clang saying that you will either not be taking advantage of copy elision or that it's not going to happen correctly. If you take a temporary, which is what this is, the value it has no name basically, and try to move it. So it's just probably from code I wrote before I really understood the difference between the different what is it, L and R. What is it? Now my brain is getting stuck. It's R something. R value, right? L value versus R value. So there's lots of web resources you can look up, and I had to read through a bunch of these before I understood what was going on. Essentially, an R value is something that's on the right side of an equal sign only. Usually that'll be, I'm sorry, it's the other way around. An L value has to have a name because it's on the left side of an equals assignment, right? R value is everything else. Some R values, like temporaries, have no name, and it doesn't make sense to move them because move is turning an R value into an L value, I think. No, the other way around. Turning an L value into an R value, but if it's already has to be an R value anyway, then move has no effect. And so just removing the standard move, it does the right thing because it knows that this is a temporary, and so it just moves it to replace what file was before. So, and here were a couple unused variables, so I had a few of those too. And oh yeah, another thing that I found was some crashes on Linux, and interestingly enough, they don't happen on Windows. I don't know why, but I fixed it on both. And that's where, and it's kind of hard to show on that screen, but in network connection, when we get some data back from the server, say, and we call this message received delegate, this goes to whatever's using our class, right? That user could turn around and close the socket on us. So re-enter this class and close the socket. So what happens if this code wasn't there? So this is the code I added, I think. Yeah, right here. If that code wasn't there, we'll get down and we'll try to potentially to send something to a socket which is invalid. So on Linux, this would be -1, and on Windows, it's invalid socket. I guess Windows doesn't care if you try to send to an invalid socket, but on, I think it was the Mac, yeah, on the Mac, actually get a trap or an exception thrown. So this little guard here kind of breaks out of the processor thread's loop if the socket ends up being closed as a side effect of calling these delegates. I guess this one, for sure, it's going to close. This one, it might close if we are closing it from the user end. And I think I put another guard up here. Yeah, so another guard up here just so that we'll break out early if the socket's closed. I suppose that can happen down here if we close, right? There's no point to continuing the processor thread's loop if the socket's closed, because the socket won't ever get reopened. The socket is a open once kind of thing for this network connection class. And yeah, that was basically it. Stuff that I did between streams. Oh, there were some errors. I did this on stream. I wrote the POSIX equivalent of looking up the IP address of a host by name. So here are some things I got wrong. So I forgot to include netdb. That defines symbols such as the structure. Let's go to the code again. What file is that in? Network connection POSIX. Like adder info. I think this struct adder info, or one of the constants here. I can't remember which one. But it probably was a struct adder info. It's not defined in the other headers. It's in netdb. And I got this if ADDR. It's actually AI ADDR. I don't know where I got that IF ADDR from, but it was wrong. I also forgot an R on this line. So compiler helped me find that. And there was another thing that was annoying me that I fixed here. I kept seeing this message processor closing and done sending multiple times, but I really intended that diagnostic to only be sent right before we call shutdown. And that only happens once because of this logic here, right? We set this flag saying we sent it. So if we end up here again, we won't try to shut down again. So diagnostic should have been inside of that if, not outside. That was more of an annoyance, not a real bug, because it only affected diagnostics. So what was this? Oh, there was a typo here where this is the read section and it said wrote instead of read, so I fixed that. So just miscellaneous things. I try not to do a whole lot of work off stream on the content that I want to show on stream, but it's hard to show stuff from the Mac side of things because I don't have a setup to stream from my Mac. I suppose I could set that up. Actually, one idea I had was to set up OBS on my Mac, and then I could take it outside and then turn on my webcam. Because I don't show a webcam on stream, even though I would like to, because of family restrictions. So Lady Raimu doesn't like me to show anything in the house, which is I'm cool with that. I just if I wanted to show a camera, it would have to be outside somewhere. Maybe I'd go to a park or something and stream from there. Because why not? I'm on a laptop, right? Anyway, that was it for the stuff I did off stream. Right, compiler errors and warnings, fixed issues with non-blocking sockets, fixed crash with reentrant calls closing the socket. Oh, okay, I did that too. Hold on, that was in another repository. So if I go to HTTP network transport, so this library exists to sort of be a glue layer between the socket stuff we were just looking at and the HTTP, the web stuff. So, okay, there were, again, some compiler warning fixes. There are some things I captured that I didn't need because the delegate's essentially empty. But this was missing, so this was also in the server side, but I forgot to put it in the client side. So when we set up this glue layer between the network connection and the web, in this case, web client, we weren't subscribing to the diagnostics of the network connection. So stuff like whether the network connection was closed gracefully or abruptly was just not getting through to our diagnostic receiver. So this sort of connected it through. And I have it again like in the server, I set the minimum level to 1 so that the really verbose messages at level 0 are filtered out. Yeah, that's essentially what I did off stream. There's an issue I found that I didn't want to do off stream, which was a little bit more involved, so I wanted to save it for now. So before we really dive into TLS, let's fix that. So the issue, I put it in the notes here. So I was playing around with Rover, and I was showing someone that I could send requests to servers and get back responses. So I happened to pick a server which, because of the timing, was not giving me the whole response back, or that's what I thought at first. The connection was being closed before the response is received, right? So I connected in the diagnostics to see more, and I saw that sometimes it would close the connection before sending the response, and sometimes after. So I installed Wireshark to study the actual exchange, and I saw that when Rover is done sending its request, it sets the fin flag. So that's done when we close the socket with SD-send. It results in sending a TCP packet with the fin flag set. So that's what's called a half close, I think, where we're basically saying we're closing our end of the socket for writing, but we're still leaving it open for reading because we expect to read back the response. But what I was saying is that the Agario server was responding with the fin of its own without sending a response, depending on timing. So it got me thinking, am I doing the right thing about half open connections or half closed connections with HTTP? Did some Google searches and found that, to my surprise, that I'm doing it wrong. So reviewing the RFC about it, I actually found the text where it says a client that sends a closed connection option must not send further requests and must close the connection after reading the final response message corresponding to this request. So basically, I have to close the connection after and not before reading the final response. So that actually makes it a bit simpler because we won't be doing this half open, half closed socket. We'll wait until the transaction is completely done, then we'll close and expect the server to close its end as well. So let's fix that. And to do that right, I should write a unit test for that. So we're going to go to the tests for the client. Is that right? Yeah. We probably already have a test for what we do when we close. Let me collapse everything so I can read the test names. Non-persistent connection closed properly is probably it. Okay, let me expand. Okay, this is the expectations which are not correct. So we expect the connection to be broken from the client end after the request is sent, but before the response is delivered. So we're going to fix this expectation. This should be false. And since it's not broken, we don't need to check if it's graceful or not. It's not broken at all. Actually, instead of deleting the code, I'm going to put in the clipboard because we do expect that stuff to happen after the transaction completes. So we will expect it to be broken gracefully. And I guess we don't need to clear those flags because we only check once. Yeah, so there's our revised requirement. So let's make that test pass. And I'm just going to run just that one test. I'm not sure, maybe some of the other tests leverage that same wrong requirement. So, but I don't want to get distracted. So I'm just going to have it filter on this closed properly test. So, right, it's not following the correct expectation. So we'll go into the client class and fix it. Okay, so it's all in the sending of the request, right? So request, all this stuff where it sends it. And here it is. So if it's not a persistent connection, we close the connection. So this is wrong. We don't want to do this here. We want to do it when the transaction is completed. The transaction is completed when it receives back the response right here. Right, the response is complete or is an error. So this is already doing the break, just not gracefully. Oh hey, multiple pixels, I am doing great. How are you doing? So we're already breaking the connection when we receive the response. I guess we can keep it simple. So in the test here, I was thinking, what was I thinking? That it would be broken gracefully? I guess we don't really care. Well, let's be explicit though, even though it doesn't really matter. Let's try that. If that fixes it, then I can move on to TLS fun. Alright, so that worked. Now let's run all the tests to make, oh, something did break. 2 tests broke. So send second request, non-persistent. Send second, send second request, non-persistent. So line, scroll. Line 16. Right, so it's again expecting this to happen. It won't. It doesn't happen. Hold on, let me think about this. Let me read this test again. So set the client, have it make a simple request using a, okay, it uses a persistent connection. But on the second one, we'd say don't persist it. Or okay, so it won't be broken until here. Okay, well, we already had that. So just basically removing the expectation of it being closed early. It might be this case in the other test too. Yeah, so let's find that one. Scroll, scroll, scroll. Line 1123. Yeah, again, it's making a request, setting the persistent flag to false, and then this expectation that it gets closed is wrong. Okay, yeah, see that happens. We already check it there, so. Okay, cool. So that's done. I can move on, hopefully, to the TLS stuff. So what I was doing is I was finishing up a fix to this bug that I found off stream. I have a huge write-up on the log for 52. Basically, I had the wrong expectation about what to do in the client when you are done sending a request and you haven't yet received a response. I was doing a shutdown SD send, basically saying I'm not sending any more data. The server was coming back and saying, okay, you're shutting down? Well, I'll shut down too, even though I haven't sent you a response back. Then I found in the RFC that I'm supposed to close the connection after reading the response back. So basically, you can't close early, even if you're a client and you're done sending your request. You got to keep even your end of the pipe open until you get back the response. Then you close both ends. So I'm fixing that up and just getting that out of the way so I can start playing around with TLS, Transport Layer Security. I'm going to be doing that real soon after I check in this code here. That was basically the fix. Don't close the connection after sending the request. And so we're basically removing a bunch of expectations. So client, don't close connection after sending request. See, also have a little note here about what I found yesterday. 6.6, second paragraph. And let's just copy that verbatim and wrap it. Actually, because it's got double quotes in there, I feel like just indenting the whole thing and not having a quote there. Wow, why is it tabbing a whole 8 characters? I just want to tab 2. Okay, that's what I want to say. Push that, and then I should be all checked in and ready to dive into TLS. Okay, so I did a few other things before the stream to set things up a little bit. Let me review that with you guys. So it's on this commit for adding LibreSSL to the solution. So add LibreSSL to gitignore, because now we're adding it as a repo, a sub-repo from GitHub. This is a check-in of the recent release of LibreSSL's basically release distribution, right? So it's not their original source code. It's their source code packaged as a release. And we're adding it as a subdirectory, but I did a few tweaks here. So they have a bunch of options that default to be a way where a lot of extra stuff gets pulled in to the build system that I don't need. So I'm overriding a bunch of these options, like turning off apps, turning off tests, turning off NC, whatever that is, skipping the install step. And then I'm right here, these lines here, I am putting the 3 libraries that you get that aren't removed from these other settings. I'm putting them into a folder in the IDE, libraries libresssl. So you'll see it now here. So crypto, SSL, and TLS. the way I understand it, my naive understanding is crypto has all of the actual cryptography and hashing functions, which is the main part I did not want to have to write myself. SSL, I believe, is like the core library that does the uses the cryptography libraries with the signing and keys, key management to sort of manage a secure connection. And then TLS is the protocol that relies on the core SSL and crypto libraries. And the TLS part is described in an RFC. And I had that open here. I was kind of looking through it. So this isn't the latest. It turns out there's an even newer one, version 1.3, but it was just released like last month. And LibreSSL doesn't support it, which is a disappointment, but it's so new that I expect it will be supported by LibreSSL soon, I hope. And so I won't worry about this being, I'll just consider it way new. So 1.2 is what, if I'm going to read about it, I'm going to read this one. So my understanding is the TLS library implements this protocol, and the crypto and SSL are sort of the core cryptography and connection management. So fold them into the IDE there. And then I had to make one tiny change to LibreSSL. So what I did is their official release, I have a link to it in the commit, and I put that in a branch called vendor. And is this, am I making that too wide? Okay, anyway. That has all the files that they released, right? So I made in master branched off of vendor, has my changes in it. So I added an option called LibreSSL uninstall, defaulted to on. And then they had this custom target called uninstall, and I basically only add it if that LibreSSL uninstall option is on. So by default, it shouldn't change things. But for me, I'm going to turn it off because I don't want to see this uninstall target. Didn't make sense for me. I just need the libraries. I don't need any kind of install and install stuff. And part of me wants to kind of take this commit and send it as a pull request back to the OpenBSD, I think it is, the guys who make LibreSSL portable, as a suggestion, like, hey guys, maybe people might not want this uninstall thing if they're using LibreSSL as part of a larger project. How about you make an option to turn it off? But till then, I keep it as sort of a little fork change, right? So, my idea for today, I didn't write it in here, but yeah, my idea for today was to just experiment with that library, meaning I'm going to modify Rover directly, sort of hack. Not worry about test-driven development, but just kind of try things out. And then if I get things to work, I will try to make a formal library that uses the TLS library. It sort of abstracts away like how you use that particular library and just make it look like network connection, the abstraction I already have. And then tie it into this HTTP network client network transport so we can use it in Rover in a way where Rover doesn't have to know about TLS. It can just say, oh, it's HTTPS, let me pull in this extra library to do that extra step of the protocols. So let's get everything all cleaned up, and we'll be looking at Rover directly. Actually, I haven't run it yet today. Now that I fixed that stuff with the connection stuff, I should be able to do Rover, debug Rover, and go to Agario and not have issues. Cool, so it's working now. And it was, I think it was wikipedia.org that wanted us, it's one of the sites that wants us to go directly to TLS, right? So a couple things we need to do for TLS. We need to go a different port number. And when we go to that port number, we have to run all of our bytes in and out through the TLS library. So how do we know to go to another port number? It's this scheme. We need to put some code into Rover to kind of look at the scheme. Okay, so we have parsing the target. So at this point, it probably is a good idea to look at the scheme, right? If request.target.get scheme, right? Let's get a copy of that. And then we'll say if scheme is... Hold on, someone's calling me, but I cannot talk to them right now. HTTPS. Then we're gonna do our TLS play stuff. Let's also, while we're at it, check for... Let me adjust my mic a little bit. Check for HTTP. Actually, let's just do a fall through. Well, no, we can just do nothing, and then we say if we fall through, then we will say it's an unsupported scheme. Actually, we need to check if it even has a scheme. I guess it's if the scheme is empty, right? Let's put that first. We'll make that an error of its own. So we'll say something like no scheme in URL. And then we'll say unsupported URL scheme. There. Here, for now, let's print a little error saying coming soon. TLS support coming real soon now. And we'll just test that out real quick. And then if I go to S, TLS support coming real soon now. Okay. So now what am I going to do? I think what I want to do is... Hold on. Hold your horses. Looks like this has already configured the client. So we sort of have a chicken and the egg problem because I think it's in this start client. Yeah, in the start client we make the transport layer. This is a problem because I need to put in a decorator or an adapter of some kind that sort of inserts an extra layer. So, maybe what we want to do is combine start client and fetch. Or actually, another way to think of it is what we do to parse the target here, we could do that twice. We could put it into the environment actually. So we have the URL of the resource fetch. Why can't I just make that a URI? Let's see. Okay, this I can fix by initially making a string, URL string, and we'll go down here and say environ. Actually, where do we do the parse? There, here we do it. So if I put that here. So it kind of goes with that anyway. So let's see how we do this. This URL string can go here. And then here we can say environment.url. And then this moves to here, this moves to here, and then moves to here. No parentheses. Oh, I got that messed up, didn't I? Just that part. So we're parsing the URL string to get the environment URL. We don't need to parse it again here. We just need to assign it. Request.target equals environment.url. Okay, so we can do the scheme stuff in start. Right here. So we can, if it's HTTP, we do not need to insert another layer. This becomes environment.url. Okay, this actually can return errors now, so let's give it the same kind of return value that process command line arguments had. By default, it'll return true. But if there is any problem, return false. And then we'll have a check. If that doesn't work, it's not a problem with the usage. We'll just say it's an error. Okay. Forgot one. So I'm making these changes incrementally, by the way. Oh, you know what? That's because there was no transport set. Right. We didn't set the transport. So we need, here's where we're gonna sort of make our man in the middle, our decorator. It needs to support this interface, client transport. So we're gonna make a class. Initially, it's gonna be developed inside Rover, but then eventually, once I get it to work, I'm gonna pull it out to be in its own library. Where to put it for now? I guess we'll put it in another file, just to be clean about it. So I'm gonna go to VS Code and make a file. I'm just more comfortable these days going to VS Code to do this kind of thing. So it's internal, so just actually let me steal from another library. What's another library I could steal from? Something that has internal headers. Maybe the web server? Yeah, here we go. So like plugin. Or timekeeper, because that's really tiny. Copy that over. Oh, I already had timekeeper. What am I thinking? Just take Rover's own timekeeper and change it. So this is TLS decorator. All right, and we will go and rename stuff. TLS decorator. Very handy to do the search replace like that, I think. Okay, and I read something today that says you should never run CMake twice from the command line. I don't agree with that though, because they say that if you build in Visual Studio or something like that, it should automatically rerun CMake if you need to. But I like to think of this, when I tell it to build, it should build, not make the build system. Plus there are some weird things that can happen where if you build the build system and the build system is different, then it causes a reload, and then you have to build again anyway. That didn't reload stuff like I expected, so something's wrong here. Did I not save that? When in doubt, run it twice. You'll see the same result because it's insane. Okay, I think it just doesn't detect the solution file changed. So I close it and then I reopen it. Okay. Now it's there. Okay, so we're going to include this guy. We need that. Oh no, not that one. It's what this guy includes. This one. Okay, so let's rewrite this. This is a decorator for HTTP client transport, which I guess we say which passes all data through a TLS connection. TLS layer? Okay, so we need to see what methods this class requires. Just one. Okay. That's not a problem. Override that guy. That becomes that. Okay. And here's the CPP file. Don't need that stuff yet. Not quite. Alright, we just need an empty body of this for now. Actually, you know what I'm going to do? Oh. We'll just have it be a completely transparent decorator for now. I'd have it do nothing. So I don't remember the formal decorator pattern, but you need to somehow initialize it to tell it what it's decorating. So it'll be like this. So something like set or not configure, I guess, for lack of a better word. And then we'll have the thing it's decorating. I suppose we will be sharing it with someone, so shared pointer to that. And we'll call that the lower layer or something. I wonder if there's a more formal or typical name for in a protocol stack for what do you call the thing below you in your protocol stack? This method sets up the decorator to use the given to decorate the given lower level transport client transport. Actually, am I adapting the correct class here? I guess for now, this is very HTTP specific. I kind of want to decorate network connection itself. We'll just go with it. I have to think more about. This will be very specific to HTTP and for client. Yeah, maybe this is not decorating the correct thing. So how would it really be? It would be this network transport. This is an integration. I guess what it would be is we would have to extend this class to inject the dependency on network connection. And then we could decorate a network connection and give it to this class. Let's start with this. So right now it will be TLS and then HTTP. I have that. Is that right? Hold on, I might be thinking about this backwards. Okay, I think it's fine because just our decorator will end up interpreting the data first and then passing it along to the lower layer. So it's really, this is really an upper layer, not a lower layer. Yeah, it's an upper layer. It's sort of backwards. It doesn't seem right, but maybe I'll discover why when I do this, and then I'll look foolish. That's fine. Don't mind looking foolish, as long as I'm learning something. You can be foolish at first, learn something, and then not be so foolish. Okay, so yeah, I was thinking right now we would just do nothing. Well, we have to hold on to this though. How come that didn't? Okay, there we go. Copy. Oh, I haven't written the documentation for it yet. This is the upper level client transport to decorate. And then I'm going to copy that documentation and paste it here. So impl upper layer is there. And then connect. Here I'm just going to pass it right through. So return impl upper layer connect. Host name or address, port, data received delegate, broken delegate. Okay, so here we will say TLS is, oh, we need to include that, don't we? Make shared TLS decorator, and then TLS configure transport, and then deps.transport is TLS. Okay, so this will end up just doing nothing but go straight to HTTP. So when I tell it to go to that, it'll still go to the non-secure site. So that worked. Now we got to change it. A couple changes to make. So the port has to be different. I always forget the default port number, but that's why we have computers these days, right? They help us remember. So HTTPS default port is 443. All right. Let's make that a constant somewhere. This is the default port for HTTP over TLS. Const expr. Includes standard int.h, right? Because we went 16T. Default HTTPS port. So if this is the case, actually I think it's here we want to do it. Actually, no, it's here, isn't it? So, really to do it right, since we have different schemes, not over TLS. So this, the default would be 80 if we're not going there. So I think in the past I was relying upon the HTTP class to fill in the default port for us, so we're going to do it this time. So here we will say if environment.url. If it doesn't have a port number specified, then we will set it. Set port. The default HTTP port, right? And then, oh, sorry, that's S. And then for HTTP, it's that. And I just realized we're modifying our environment when we do that. I suppose that's fine. Should start client modify the client's environment? Or should we do it in this process command line arguments? Maybe we do it there. Yeah, we're already parsing the URL there anyway. So we'll do that here. Just that part of it though. I need to get the scheme, don't I? There we go. We're setting the default ports there. Then I don't need to set them here. Now it's going to try to do TLS. No, it's going to try to do HTTP over a TLS connection. Let's try the unsecure one first to make sure that still works. Now this, it's going to totally fail. Yeah, see. It actually is smart about it. It says, oh, you sent a plain request to the wrong port. It's actually kind of nice. So this is maybe a good point to check in, because we're about to try some dangerous things here. So this is already in Rover, right? So set up skeletal TLS decorator, and I use URL scheme to select it. Okay, that's good enough. Good enough for government work. Okay, is my mic working? Yes, it is. So awful quiet, so I wonder if like my setup is working. Seems to be. Okay, so next. We'll do some actual decoration here. So we're going to need to decorate each connection. So we're going to want to do the same kind of thing that we did for the decorator itself. We'll do inside the implementation of the decorator. And we'll call this one connection decorator. Maybe we'll call it TLS connection decorator. Just to make sure its name is specific. I ran into a problem yesterday where I had like a generic name for a class inside of an anonymous namespace, and another piece of code had its own anonymous namespace with its own class with the same name, and the debugger got confused. So I want to avoid that problem. This is the connection. Okay, this can actually be a struct because we don't really need a distinction between public and private APIs. Which means I really don't need lifecycle methods declared, do I? So here it will decorate a connection. Connection. This class has a bunch of methods, so we need to implement them all. Actually, these are type defs. Here are the methods. Decorator. And here we go. Okay, I'll basically call this methods. And we have properties, which means I probably don't need a configure. I can just store it here. Right, and I don't need a constructor either. Override. So we're basically going to override all of the virtual methods and do the right thing. Okie doke, so no private properties. So when we're asked to make a connection, we will make another adapter. So const auto connection decorator. Make one of these. TLS connection decorator, right? And then its upper layer will be to make a new HTTP. Oh, okay, here. Okay, yeah. This is really what HTTP client network transport does. Okay, right. So we do a impl upper layer connect at this point. And then we return the connection decorator, right? So it's just another level of decoration. Now, if we wanted to pass this through, we would simply pass through, which we should do by default. Pass through all the methods, right? These are all voids, so it's... So basically forwarding everything. Oh, right. We can actually make sure that this is still working if I hack this back to be... Actually, I don't even need to hack it. Back here, when I run it, I can say it's at port 80. And it should still work. Right? Because it's still forwarding everything through. And I just don't want to go to the default HTTPS port. And this will say, oh, you're still using HTTP. All right, so now that we're decorating the individual connection, we can introduce libtls. And this is where it gets a little funky because I don't know how to do it yet. And it looks like I closed my window that I had open for that. Let's try to find it back. My research, I had... What was this tutorial? I was kind of following this tutorial along. Where was it? Oh, no, it wasn't that link. It was this other link. Because we're a client, I was like looking at this client code to try to get an idea of what we have to do. So it talks about how you call TNS in it. Okay, that's fine. Although I think I read that you don't need to call it anymore. That in the latest API, it's called for you. Yeah, it's no longer necessary to call this function, since it's invoked internally when needed. Okay, so we can skip that. There's TLS client, right? Before connections. created, a configuration must be created. So they do that here. Interesting. They create the client, but then they create the config next. Let's do what this recommends. So this recommends doing the configuration first. Then create with TLS client and configure with TLS configure. Okay, so it's TLS config new that we got to call. And actually, I'm inclined to make this a class again, because I kind of want this not to be touched directly by the outside, because why, right? And we'll say private. It's a private properties. Properties. Oops. These are public methods. And we'll say void connect, pass in one of these guys. I'll say this method, not connect, configure. Well, maybe it is a connect. Is that what we're really doing? I guess so. So connect. So this method establishes a TLS connection. I really have the concepts of upper and lower inverted here. Really, this is a lower layer. No, really, it is an upper layer, but we're adapting in the other direction. Yeah, we're adapting in the other direction. So this method establishes a TLS connection. They call it a TLS connection? Right, a TLS connection, and establishes a TLS connection and sets up the decorator so that all data passes through the TLS connection. All right, so then I can change this code here to say connect. This the other way around, right? Oh, it's just connect. So this upper layer makes a connection at the TCP level, and then we connect it to TLS. So here we go, TLS. Okay, to get it, we need to include TLS. And we should have that now. Oh no, we don't have it yet, because I haven't set it as a dependency. And here's where all sorts of fun things could break. When we try to link with TLS, what's going to happen? I did notice something in their CMake files that was a little bit disturbing. In their TLS CMake file, they have this target link libraries, but only if you build it as a shared lib. And I'm like, why did they do that only if you're building a shared lib? We're not building a shared lib, so we might have to include those in our dependency list, even though we shouldn't need to. I think the proper thing to do would be this. Actually, it's Yeah. Actually, it's all of this, isn't it? Well, at least these two lines I think should go there. Because if it's not a shared library, it doesn't build in a link to that when you build TLS, but it makes it so that if you link with TLS, it'll pull in these as well. But we're not going to modify theirs. We just might have to pull these in ourselves. Right, so I might see that when I get to here. I might have to add those two as well. Let's see what happens right now if we just do this. Probably it'll work because I'm not calling anything in it yet. I want to at least be able to find their header file though. Oh, there it is. Alright, so we can is it new? Config new. And then it returns a TLS config pointer, so we need to hold on to that. How about we use a shared pointer? This is the configuration structure used with TLS. How about this? This is used to configure the TLS layer. Standard, actually we're going to make it a unique pointer because I want to get into the habit of that. And the type, TLS config. TLS config, I guess. So what we'll do is we'll say TLS config.reset. Or was it that we assign it? This guy. Okay, where was it that I used this with a deleter? I had to make the second template argument distinct. Oh, here it was. Right, I had to use standard function and a type that takes that pointer back. So that's functional. And actually, I like to include the local headers first. Right, so this I need to be explicit and say it's a function that returns nothing and takes a TLS config pointer as an argument. Now I can say TLS new and then TLS config e. I can say what are we supposed to do with it when it doesn't like that. What does it not like? That looked good to me. No instance matches a list. Cannot convert initializer list. What? Oh, I got the template wrong. How about, can I just do decal type? Ah, look at that. I like that. It's like make one. And yeah, okay, so what does the manual say for how do you destroy one of these guys? Config free, all right. TLS config free. This is wrapping C in C++, right? So they say, don't forget to call TLS config free. And I'm like, I don't need to forget. I'm going to use the unique pointer to do it. Safe to do it as soon as the final TLS calls. Oh, it's okay. We'll just do it whenever. Now we don't need to care when we do it. So make one, and then what? Let's look at the example. What do they do? Insecure, no verify cert. I don't know what that does. What if we just use the we'll just try the default. So you do then TLS, so you make a client. So we need a client, and that's just a TLS, it looks like. So TLS client, the TLS, so another one of those. So this is, this implements the TLS layer, I guess. It's just a TLS. That might be ambiguous. How about we say impl? And then we can say TLS impl equals decal type TLS impl. That doesn't need any arguments. And then we have to dispose of it when we're done. And let me guess, it's TLS close or something, right? TLS close, TLS free, alright. TLS close P, TLS free P. Awesome. Okay, is that all we need to do to connect? They have connect socket, but here's where I wanted to take advantage of some of their new API. They have listed here an alternative. We look at like TLS read, for example. Maybe it wasn't TLS read. Maybe it was TLS connect. Yeah, here we go. They have connect with callbacks, which I really like the idea of that because I use callbacks. Those are what I call delegates. So that will match up to maybe pretty closely to what we already have. So the idea is we're going to call TLS connect CBS and it could return an error though. So we're going to need to have a bool here. Copy from something else. What maybe in our main. Yeah, here we go. Just like to copy rather than rewrite it. Indication of whether or not it's exceeded is returned. All right, so return and it what? 0 on success. So TLS connect callbacks. And it wants the context first, so that's TLS impl.get. And then it wants a read callback, a write callback. Let's just write them out. Read callback, write callback, callback argument. This, I guess. What's server name? Server name. Wonder what that is. Well, I know what we can say. Pepe. Because why not? I don't know why they want a server name. Oh, maybe it's the host name. That could be it. They want to know the host name. That's known at some point, right? Yes, this thing. So what if we pass that in? We'll call it server name. We don't know exactly what to, if it's exact. I'm just making a guess that it is the host name or address. And we'll pass it in here. Okay, so server name. This is, I don't know, the name of the server to which, with which. connect as a TLS client. I'm going over 80 characters, so let's wrap. Let's wrap. And if I could wrap, I would wrap right now, but I don't know how to wrap. Okay, so these need to be what? What are those things? So they are pointers to functions. Right, so what we can do, I happen to know that a lambda that captures nothing can take the place of a pointer to a function. We just need to cast this, so I need to make sure the arguments are all the same, though. Maybe I'm wrong. Maybe I am wrong. Doesn't seem to have liked that. Oh, because I'm not returning a size t. Return 0, I guess, for now. There we go, now it liked it. The red squiggly went away. Alright, so right callback is similar. It's actually exactly the same, isn't it? Oh, no, it's not. There's a const in front. Almost? No, it was here. There we go. So instead of doing that return, we'll do our thing. So what do we do when... Right, so this first argument is the CTX, so we get it back as CTX, so we can basically cast it back, right? No, it's CBArg, actually. Oh, yeah, it was the this passed in the next to last thing, CBArg. So CBArg ends up being this, so what we want to do is cast that back to TLS connection decorator. I like to use self, and actually we'll take advantage of auto here. CB arg. I'm not a fan of using this leading underscore, though. You have to be careful. You never want to do that with a capital letter. It's okay here with lowercase letters, but underscore capital letter is like a reserved word, I believe, in either C or C++ or both. Okay, and anyway, we're going to do that in both callbacks. So this is the callback when the TLS layer wants to read from the underlying TCP connection, right? So here's where we got to do what's called a push to pull. So we're going to get pushed in data, this send data, right? Oh, wait a minute. It's reading. So it's this data received delegate. This data received delegate will be called when we get data back, and we have to kind of store it to be given back to this callback. So we're going to need a buffer. Is this already... Okay, this is the type of the buffer. So we'll establish a buffer here. Receive buffer. This holds data received from the lower, well, it's the upper level client connection before it's read by the TLS layer. So again, it's sort of an inverted decoration right now. It should be the connection's lower and TLS is upper, but right now TLS is lower and the client is upper. Just because I have screwed up names, but we'll fix that at some point. I just don't want to get distracted too much. Okay, so there's the receive buffer. Here's what we're going to read out of it. So I suppose what we'll do, and I need algorithm for this. Is we'll say const auto amount equals the minimum of what they asked for, right? And then how much we have. Self receive buffer dot size. All right, and then we're going to return that. Although I got to be careful. I don't know what the meaning of 0 or -1. Like, why is it a negative? And here's where they don't really have a whole lot of documentation, so we'll have to kind of see how it goes. I suppose I could look at the actual code for LibreSSL. Set callbacks. And then they have this context read. So where do they actually call that? Okay. So there's special constants. Want to pull in, want to pull out. Oh, okay, I was reading about this before. I think I was reading that from here. Want, yeah, here we go. Asynchronous, here we go. Okay, so do they talk about the callbacks in this tutorial? No, they don't. Shoot. I kind of want to find an example code that actually does this, so I'm not kind of just guessing. How about example? How about this one? Block, I don't block. Yeah, so I want to look at get3. By the way, what license is this under? GPL. Hmm. Hmm. Can we look at one that's not GPL? Hmm. How about this one? Ah, so Python libtls, we could maybe look at that. Python libtls, what's the license on that? I'm looking for where it's hosted though. Would they list where it's hosted here? Don't see it. BST, which is good. Okay, forget that. I don't want to look at GPL stuff. I want to look at more open stuff. So okay, yeah. From here, I want to see if I go. No, this is just the documentation only, isn't it? I'm just wanting to see if there are sources available somewhere. How about if I just look up libtls source? Maybe not. Okay, back to the old search then. Can I look at it here? The discussion forum? This is always sort of usually a miss. Okay, this is discussing code changes to libtls. Well, I don't know. I guess we can just rely on looking at the source code here. I suppose what happens is if you have no more data and it's the end of the connection, you'd return 0. If you have no more data but the connection's still alive, you would maybe do want poll in. Right? I'm going to guess that's what we'll need to do. So it will be let's keep a flag actually. So a flag called open. Actually, let's default it to true and say this flag keeps track of whether or not the upper level client connection is still open. So if we'll say if amount is 0, if it's actually a special case, right? If amount is 0 and not open. No, and it's still open, right? Then return whatever code they wanted. TLS want poll in, right? Do they have a documentation for that? No, they don't. Gotta love it. No documentation. This is self-open. And I gotta be careful about this being called from different threads, don't I? So minimally I need a mutex. And let me think, will it be called recursively? I don't think so. So we can simply make it a normal mutex. This, in my standard comment, this is used to synchronize access to the state of this object. Right, so here we will make a lock guard decal type self mutex. We'll lock the mutex. Wait a minute. It's a pound define. Why is it undefined? I don't know. What's going on here? Oh, I think it's just getting confused. Did that unconfuse it? It's still confused about that. It's interesting. It says it knows it's a pound defined to -2. It expands to -2, and it says, oh, it's undefined. Wait a minute. Didn't you just tell me what it was defined as? Weird. All right, so that's the special case, I believe. That tells it that it should back off from trying to read because we need to wait for more data. And then it's going to be a similar, I believe it's a similar pattern for writing. So it would be, no, it's not going to be the same kind of pattern, actually. It's going to be a direct send, isn't it? Self upper layer. How come I can't access it? Weird. I don't know. My IntelliSense is maybe weirding out. So send data. Okay, so this, yeah, it's always asynchronous. So we can vector uint8t buff plus pufflen. Underscore buff. Actually, you can't add to a void pointer, can you? So we will make a const uint, const auto buff bytes, and we'll cast to const uint8t the buff, right? And then we can say that and that. Leave them separate lines. And then we always return bufflen. It'll never want to pull out. Is that right? Yeah, we'll always be able to asynchronously accept bytes to write back out. Okay, so that's that end. Next, we do forward these. This one we got to be careful about, though. Right, so what we want to do, this delegate is what hold on, how do we get, there's two callbacks. Oh, it's TLS read, TLS write, isn't it? The examples here. Yes. So let's do the broken one first. So the broken one is what we should call I'm getting my directions confused here. All of these are going to be called by the lower layer. So it's going up, right? Oh, I got my names confused again. Hold on, I need to stop and think about the names and directions here. Right, so it's going to be the unencrypted side when we send data. We want to end up calling TLS write. And when when data comes back in, we want to call TLS read. And this is when, hold on, broken delegate. No, this is what we want called, yeah. So we need to set on this upper layer a broken delegate. Yeah, so back up here. So up, no, I forgot to even store that, didn't I? That would be bad. We need to do that. That's not good. Okay, I'm gonna do, I should have done this before. Private properties should have underscores afterwards. Should have done that earlier. Okay. This compiles, right? All right, so we need to set its data receive delegates up. Let me think about this. Is it safe to capture this? We're decorating it, so we have a strong pointer to it. So that is safe, isn't it? No, it's not safe. This is a callback, so we should have a weak pointer to ourselves, so... Oh, wait a minute. Hold on. Actually, when we destroy... Yeah, when we destroy... Yeah, when we destroy this upper layer by releasing it, then the delegates will be destroyed too, so it's safe to capture this. I've convinced myself. Hopefully not an error. Alright, so this is how the data comes in. When the data comes in, we're going to put it into the receive buffer, right? So, self-receive buffer. It's just mutex. Receive. Okay, the IntelliSense is giving me a really hard time. Alright. So when data comes in, we just put it into the receive buffer. And then hopefully then TLS will eventually check again our callback. Upper layer set broken delegate. I think this was like graceful or yeah, graceful. But actually I don't really care. It's just going to get the lock and then set that open to false. Okay. Does not support half-open connections. Now that I think about it. Right, so let's do this. This one was more straightforward. I know I'm going to do a write. Actually, this is where I was reading about this, where a write might require a read because there's handshaking to be done. So this could block. Hmm. But we're always going to be calling this from the top layer anyway, so maybe it's okay that it blocks. So we would need to really do this in a loop. Well, what are the semantics of TLS write? The context, so that's TLS impl.get, buffer and buffer length, right? So that's data.data, data.length, or size, and that has an underscore. And it returns how much was written or one of those special polling things, right? So let's say const auto amount. This send data, we already do that here. We don't do that here anymore. Right, so we might send it in pieces because of how it has to maybe wait for data to come in at some time. So yeah, I think I know what I want to do here. We will have a condition variable. We'll have a condition revolving around receiving data. So this is used to alert any threads that might be waiting on changes to the state of this object. It's just basically very generic. It will be coupled with the mutex standard condition variable. And we call it wake condition. Or wait condition, I guess. Actually, I like wake. You wait on the wake condition. So when we get data in, that's in this received delegate here, right? We'll do a notify all. And essentially we're going to be waiting here. So size t offset, while offset is less than data.size. We'll be trying to write some amount, so it'll be data plus offset, size minus offset, right? And so if amount is this special want poll in, then we gotta wait. So around this whole thing, we need a unique lock. Decal type mutex. And these all have underscores on them. I forgot. Keep forgetting that. All right. Amount is TLS want poll in, so we will go on an infinite loop. We want a way to break out if the connection is lost. Yes, so we need to also do this here if we lose the connection, right? So one of those two things will happen. But we also want to... Okay, I do want lifecycle. That means I want lifecycle management. And where do I do? Where do I have a template for that? Any one of these places. Okay, here's one. Lifecycle management. Array for lifecycle management. Okay, we can default these safely, I believe. Oh, wait a minute. No, we can't. We can't because we got mutexes and junk. Delete those guys. Okay. What I want to do for this destructor is call break. If upper layer is not equal to null pointer. The reason for that is it might get stuck. Actually, this class will automatically call break. Maybe I don't need to do this at all. Definition of, well, that's a base class. What does the actual underlying class do? That's this one. It's up to this guy. So what does he do? Okay, he just does a default. It's his implementation, right? I think it destroys the connection, so it should be good. I'm not absolutely sure. Oh, yeah, okay, so it does that. So I guess we don't need to worry about it. So, you didn't see that. Nothing happened. Okay, connect. Right. Doing this wait. So, wake condition dot wait on the lock, and the condition is from our own state. Return either not open or not receive. It's not helping me. Empty. Right? So wait for either until we're not open anymore, or the receive buffer's not empty, and then it will repeat again. If it wants poll in. We'll never get the poll out the way we wrote our code though. Because it's asynchronous. It'll eventually all get written out. So it'll usually write it in one shot. It's only if there's a handshaking in progress that will go here. And we'll end up waiting until we get more data in, and then it'll try again. Okay, and then we should do an else. Offset plus equal to amount. I suppose we should check if it's less than 0. What if it's equal to 0? Does that mean it's closed? We'll consider it an error. So we will do an upper layer break, I guess. Okay. So we did the TLS write. Where do we do a TLS read? It's in this data received delegate. Oh, this is the other direction. This is a pull to push. We need we need a thread that actually tries to read constantly. Actually, then we should just, if we're gonna have a separate thread anyway, we can pull this code into it as well. Yeah, okay, so let's do that. So we'll need thread. And let's make a thread. Actually, it's going to be two things. Thread worker. This thread performs all TLS read write asynchronously. And then we need a flag. So this flag is set whenever the worker thread should stop. And that's true at first, right? Because what we'll do... Oh, yeah, okay. And that means I do need my life cycle management. Because we'll want to stop it. We'll want to stop it first, actually, before we let anything else get destroyed. So, if worker joinable, we need this mutex. Actually, it's going to be a... Well, no, we can do it this way. And then stop worker equals true. And then we say worker join. And then in connect, let's put a guard in here. So if worker joinable, we return false. So we don't connect twice. So then, after, we have to do it after we set everything up though. Okay, we can do it at this point. So worker equals standard thread, the address of our own class, worker, and pass it one argument this. And before we do that, we'll say stop worker is false. Now we just need to make that method. That's a private method. Void worker. Okay. This... Oh, my printer is again reminding me I'm low on ink. Thank you, printer. This method runs in a separate thread performing all I/O with the TLS layer. Okay, it's the standard formula, so it's the same unique lock that we use when we're waiting. And then it's while not stop worker. And then we need to do a wait. So wait condition. Wait lock. This return either. Okay, couple of conditions. 3 actually. Let me fix my indentation here. So, and I need to introduce the send buffer because it's going to be fully asynchronous. This holds data to be sent. Oh, really? Sent from the upper layer client connection before it's written to the TLS layer. So 3 conditions: either stop worker or receive, not receive. Oh, wait a minute. A receive buffer empty is fine, isn't it? Hold on. I was saying before that this code I might want to move into the thread. Actually, I still do, don't I? I think we're going to be doing alternating between TLS read and TLS write. So it's going to be receive buffer. I don't know why it's not. IntelliSense it's not working. Or send buffer empty. Is that right? Right, because of this condition. Okay. And we'll do that last. So what we'll do here is we'll say if not send buffer empty, then we'll try this here. Then we'll try to write from send buffer data, and then let's see. I guess it's more efficient. Is it more efficient to have an offset? No, I guess we'll just rewrite the, we'll rewrite the vector every time. Actually, didn't I have a class for this? Where did I write that? Is it a network connection? I'm looking for it. I don't see it though. Maybe it was somewhere nearby. Not WebSocket. I don't need, maybe it was built into here somewhere. Like it was some kind of data queue. Didn't I make something called data queue? I did. Right, right. I think maybe we should use one of these because it's more efficient rather than these vectors here. So let's do that. So st system abstractions data. How come it doesn't show up? Is it not public? Oh, it's not public. Shoot. Well, maybe let me make a note to consider making that public. Consider making system abstractions data queue. Like, it probably belongs in the same library I haven't brought in that does other kinds of data structures. So probably maybe bring that in around that time. But for now, we'll just always, what we'll do is, instead of doing this, we'll rewrite that vector, send buffer. I think you can just do this, right? Begin, send buffer, begin plus this. Actually, it's if st amount equals send buffer size, it's easier to just do send buffer clear. I think. I don't know if the standard template library is smart enough. When you call erase, if you erase all of it, does it do a clear? I don't know. I think we want to stop ourselves if this happens, actually. Actually, I can maybe improve on this a little bit. While not stop worker and open. Because when we close, we don't need to do anything more. Okay, so we don't need to do this wait here, though. That wait we already do down there, so we don't need to do anything. Nothing to do. Just wait. Nothing to do yet. Nothing. Can't write any more until we read some more. And I suppose it's okay to keep calling that and keep getting that, right? So each time we wake up, we'll try to write if there's something to write. And then similarly, if not receive buffer empty, oh, you know we're going to have two different buffers, aren't we? Oh, no, no, not necessarily. Not necessarily. So I just need to have like a scratch space. So something like, okay, this is receive buffer secure, and this is receive buffer insecure. Insecure? Unsecure. Holds data received from the envelope before it's read. This holds data received from the TLS layer to be delivered to the data received delegate, right? Which we are going to need to hold on to. This is secure. Okay, this got removed, right? So it's all synchronous now. It's send buffer, insert send buffer end, data.begin to data.end, and then wake condition notify all. Could probably get away with what notify one, but if I do notify all, I don't need to remember that we only have one thread. You can have a second thread that starts waiting, and then this still works. Okay, so I think for these we just store them. So data receive delegate is that, because we're going to call those later. So we have these right around here. And then the other one, this one. Okay, this is the method to call to deliver unsecure data received from. Oh, hey there, Jesse. Rating with 4. Thank you very much. How was your stream? And how come I didn't get an audio blurb? That's weird. Audio working? Checking. Okay. I guess I'm using Chatty as a desktop client for Twitch chat, and it does a little tone whenever there we go. I guess it's sometimes working and sometimes not working. But yeah, when someone raids me, I don't usually, for some reason, I don't get an audio cue. But I happen to see it out of the corner of my eye. Lots of effort and little impact. I learned a lot from watching you, though, about JavaScript. A lot of things I still need to learn, so it was very interesting. And hi there, Mater. How are you doing? So yeah, I'm working right now trying to make a class that kind of sits between sockets and libtls, and sort of arranging the plumbing right now. So it might be a little bit esoteric until I actually start running it, and you can see it break horribly. So yeah, this right now I'm writing the state for the function to call to deliver, it's really not unsecure data, it's data received from the TLS layer. not receive, but what do you call it? What do you call the data that comes out of TLS? Deliver. The underscore at the end of the variable name, it's not really standard. It's more like a style thing. I like to have underscore at the end if it's a private property, just to, I guess, to reinforce in my own head that it's not public. Unencrypted. I suppose so. Call data to deliver. How about data received and decrypted from the TLS layer? Okay. How about that? And this is the method to call whenever the underlying connection has been broken. Okay, so let me handle the broken one first. We get told that it's broken here. Right now I'm just setting the open to false, but I guess after, here's what I'll do, just to be real safe. Actually, do I care if set broken delegate races are calling of it? I guess I don't. So I can just call it. I don't want to call it while holding the mutex though. I'm trying to avoid that, so that causes deadlocks. But I can call it here. If it's not null, of course. PTR. Okay, why is it not like me calling it? Oh, it wants a graceful flag. Okay, sure. You can have that flag. And then this is, I renamed that one, right? It's unsecure. No, it's secure at that point. It's secure, and then we wake up our worker thread. Our worker thread down here will wake up and see it come in here, and then we'll try to read more from TLS. Const amount TLS read. So it's the same kind of formula. Same kind of formula. So yeah, still can't read anymore. Because we're out of data. This ends up calling our callback up here, I believe. This one. And oh, this is secure again, right? And if TLS says that it needs more, then it'll tell us that it needs more, and then we'll not try again. Copy, paste, make a function. What's that? Copy this, pasta that. Oh, I've seen that before, now that I think about it. I copy pasted it, but just to avoid some extra typing. The read and the write are similar. In fact, they're kind of intertwined. The reason why you try to write to TLS and say it might pull in, basically it needs more data, is because a write could cause a read callback to happen if it's in the middle of a handshake. So, you know, like you've written out your query and the server responds back with a challenge, or you're waiting for the server to reply to a challenge or something, you'll get this. And it says, well, we can't write it anymore until we read some. And then we'll read some and data becomes available, and then we try to read it. Or I suppose, yeah, so we try to read it. Sort of weird because the read and the write are intertwined in TLS. I'm trying to understand it now. What I'm using to try to figure it out was there's this tutorial on libtls that kind of went at a very high level. And then there's some examples which are pretty good that I found on this guy's GitHub. And then just the manual pages. So I had that under my research tab in the OneNote notebook I have below a link to, that I had found these links in here. And oh, by the way, Unfortunately, the one I picked, LibreSSL, doesn't support the latest TLS, which just came out last month. But I'm not letting that stop me. So anyway, if you look at those links here, you'll see it's not a simple API. When you read, you might have to write, and when you write, you might have to read. But right now, I think the only way to really block is if it's waiting for data from the server, which is this want poll in. I'm assuming if we get any other kind of error, it's bad, and so we break. Okay, here's where I don't want to read into my send buffer. I wanted to set up this read buffer unsecure. Where was I? Here. And we just need to give it space to begin with. So when I construct our class, I guess I'll just, okay, I don't even have a default constructor yet. So let's make one. This is default constructor. I really just want to resize it to some kind of default. Default unsecure. Maybe you guys came up with better names. Unencrypted or decrypted. Let's fix that. Unsecure is now decrypted. Decrypted is the new unsecure. Except for the constant name. Oh well. Default decrypted buffer size. Actually, it's never going to change, is it? It's just some scratch space, so it's not a default. It is what it is. We'll just need to give it a size. The number of bytes to allocate for receiving decrypted data from the TLS layer. Alright, so const expr, size t. I don't know. How about 64K? I like that number. It's somewhat arbitrary. Although if you expect huge amounts of data, that could be an arbitrary bottleneck. So in like a real professional implementation, I might want to make that a configuration item that you can change from the client side, but I'm just playing around, so for now I will just make it a constant. Where did I use that? I was going to use it in the, okay, you already used it there. So we let it read into that. Right, so if we get any data at all, hold on, if it's 0, it's sort of bad, isn't it? I guess 0 would mean there still is, just isn't any data. So if we actually get some data, then we just send it. So it's if data received delegate's not null, we'll just give it to them. And that is, okay, first, oh, I know what I'm going to do. I'm going to resize here. This guy. And then where I resized it earlier, we'll just do reserve. Because then here I can do a trick where I just say resize it to the amount. And then I can just pass it as is to the delegate, and then we're done. Although I gotta be careful, I don't want to call that while this mutex is locked. Just in case it re-enters, so we will unlock it, and then lock it again. And I just have to be aware that state could have changed at that point. I think that's okay because the next thing we just do is wait one of our wake-up conditions. If this compiles, I think I'm ready to just dive in and see if it works. And what was... Oh, it doesn't even link. Oh, bummer. Oh, I think I might know why. Talking about this earlier. I think it's a defect in libtls. If you look at their CMake file, they specify what target length libraries are, but they only do it if you're telling it to build a shared library. I think this ought to go outside the if. Since it's not, though, we'll work around it by when we specify our includes, we will list those as well, like that. Oh, sorry, I missed some chat. Something's wrong with my audio and I'm not getting the cue. So let me roll back into history. You're asking, 64K is a good number for buffers. What happens when the amount of data is more? I think what will happen is it'll just repeat the read again. Oh, I'm in the wrong program. This read. Oh, actually, it's gonna. That's a problem, isn't it? We should at least read one more time, right? Let's have it. It's got to empty this though. When does that get emptied? Oh, that gets emptied when this. Okay. So what happens if if it only reads 64K and there's more data, is that the secure buffer won't have been completely emptied. Oh, that's assuming that TLS reads all that it can. What if it doesn't? Or what if it buffers stuff? Okay, so yeah, you've made me think of a bug. So if it reads only 64K and there's more, we need to try again. So I think what we'll do is have a flag for that. So bool try read. We will set that to true whenever more data comes in. Actually, it doesn't matter. We'll just say if there's any secure data or the try read flag is true, right? And we'll only stop if we get 0 back out. So try reads false. When do we set it to true again? When this becomes true. So basically, anytime we get back in here, set it back to true. So it should keep going into this and trying to read more, and only stop trying if it amount is 0. Should I be explicit about that? It's sort of redundant. Less than 0, greater than 0, the only alternative is equal to 0, so we don't try to read again unless we get more secure data input. Okay, so the next chat. Does TLS only read data into the buffer up until its size? Yeah, so it's supposed to stop, and I guess it either buffers or doesn't decrypt any more data than what you ask for. Should the if statement become a while loop? Well, we're already in a bigger while loop here. And I think it's important to alternate between writing and reading because of the handshake stuff. Because we might get into this case where we can't write anymore until we read. And probably the same thing, we might actually have to catch that and just not bail. Pull out. Can't read anymore until we write. Although write always succeeds, so we shouldn't. I think we shouldn't ever get here. But let's see. How do we check that? How about try read true, and I'll just set up a breakpoint there. So that when we're debugging, we'll hit that if it ever happens. Should the if statement... Yeah, okay. Uh-oh. My dog's starting to bark. Someone might be coming home from school now. Yeah, so that's the overlay I have to throw up when my dog starts barking and someone just came home, so that's why. Anyway, so everything builds and links, so I don't know. YOLO, let's give it a try. Here goes nothing. Interesting. So it got stuck. Don't know if it actually read anything. And I had to control C out. Let's try running it in the debugger and see what's getting stuck. HTTPS. We're hitting wikipedia.org today, right? Yes. All right, so let's just go. Okay, so it's stuck. Let's see where it's stuck. Okay, it's in the TLS right. It's trying to print something. Interesting. It's trying to set an error. Context not connected. Eh. Interesting. So I'm trying to write to a context that's no longer connected, I guess. Maybe I did the... oh, we're in the destructor. That's one thread. One thread sitting in the destructor. Okay, so I have no idea what's going on. So that means I'm going to add a bunch of print statements everywhere. So what's the first thing it's going to do? It's going to try to connect, right? So let's print that out here. Oh, print F needs standard IO. So TLS connect CBS. Okay. And we'll put a print here in the callback. What did they call it? Read CB. And we'll print out how much data they tried to read. Bufflin. And the right callback. And when this is when we close our end, break our end, broke our end. And this is where hold on, I'm not understanding this again. Yes. So received secure data. This is not that our broke our end. Broke other end. Other end broke. Okay. That's one side, and then the other. Sending. Or really it's queuing data to send to TLS. Let's put a count in there. And this is breaking our end. Okay, and then in the worker. Let's print when we wake up. Wake up, sheeple. And then we're trying to write here. We'll say how much we're trying to write. Then buffer size. Okay, let's print. Let's just print this. And copy that down to here. And this shouldn't happen anymore. And I don't need this dummy anymore. And let's print something here. TLS read returned. Let's just convert it to an int, because I don't remember what the printf thing is for s size t. Mount. Error. This, though, it should be an integer, or a size. That's right, actually. Oh yeah, you're right. Thank you. Although I'm gonna, hold on, that really belongs down here. And this belongs down here, right? And then this becomes right. And then we should say that we're going to try to read something. Yep. Why is Visual Studio CMake so garbage? Did you forget a kappa, I hope? I don't know. They've been trying to integrate CMake into Visual Studio, but I haven't really tried it out much, other than to complain to Microsoft that the version of CMake they had integrated was old. Alright, so let's just run this and see what it does. Whoa! Okay, we're in some kind of weird loop. Oh, error. Let me output that so I can look at it. Oh, wait a minute. Why did we try to read? Oh, we tried to read before we did a connect. I think I know why. Because I started the worker thread too early. TLS connect. Yeah, we should connect first and then run the worker thread, right? And this, let's just do an early out if this fails. If that's not equal to 0, this looks ugly. Okay. This goes here, doesn't it? And then this becomes that. And then we'll just assume everything's good, except we will start our worker thread. And let's print something here too. TLS connected. Starting worker. Oh, and I wanted to print when the worker thread starts and when it stops. Worker starting, and then worker stopping. And while we're at it, let's print something in the destructor. Atom nuke. There's an atom reference. We're nuking everything in the destructor, right? Okay, let's try this out. What? Oh, did I not wake up the thread when I queued something? Yeah, how do you guys like Adam's new atom nuke thing? He doesn't nuke code a whole lot, but it's sort of funny when that happens, isn't it? Okay, it was in send data. Am I not? I am waking it up. Okay, so it shouldn't it have tried... Yeah, queuing? Oh, wait a minute, wait a minute. The connect isn't returning. The connect must be blocking. Okay then, so I didn't know that. I didn't know that it would block. What did they say about connect? Connect. Where are you? Connect. What are we looking at? Config. Connect. Oh, did I not configure it? I might have forgotten to do that. Yeah, I forgot to do that. That's dumb. So it's TLS configure, right? Don't remember. What does example say? Yeah, it's TLS configure. How come? Is it a macro or something? It's a structure. Oh, it's configure. There we go. So the TLS ample dot get, and it needs a TLS config dot get. And that does return something, but the example doesn't actually do anything with it. I'm assuming it's returning an error. Okay, it's just for allocation things, so it shouldn't ever... I don't know, might as well. Return false. Do I have a return? I do have a return false. Okay, good. Try it again. Wait a minute, it's getting stuck in configure? Why would it get stuck in configure? Oh, wait a minute, it might be returning false. Wait a minute, shouldn't I be checking that? Oh, okay, where do I do that? Startup client, start client. Okay, then. Do I not call connect? I call connect down here. No, request calls connect. Oh, wait a minute. I think I messed up something here. Yeah, see, I did not do anything with the return value. If it fails, return null. I believe that's my API. Yeah, I know it's a lot of code. Sorry about that. Yeah, Adam Nuke, so it failed. Configure is failing. I'm not configuring it right. So what does the example do? Maybe I need to call these. Let's try that out. So TLS configure, where was that? I'll just do exactly what the example did. That's this guy. Huh. It's not getting past TLS configure. Unless, did I misinterpret that? Is it 0 is okay? Oh, okay. I'm looking at the wrong function anyway. It's configure. It's 0 on success. Okay, I'm dumb. It's if it's not equal to 0. Oh, is connect the same way? 0 on success. So, oh, I already have a not equal to 0. I get that backwards sometimes. Think you need to store TLS config get in a var? Well, TLS config is a unique pointer. Hold on. It'd be easier if I'm from there, I do go to definition. So it's a unique pointer, and I use that so that I can have this function called when it goes out of scope. And that function I have right here, it calls TLS config free. This is like a nifty little C++ wrapper for C, right? When you call config new, you want to pair it with the free to be called when the unique pointer is destroyed. Let's try that. Ooh, I got a crash. Configure, connected, starting worker. Worker starting, it tried to read 64K, it queued 62 to send. It tried to write 155 bytes and then it crashed. Getting further. I think I do not have a new line on the connected. Oh no, that was one line. Worker starting. Okay, so it's in the right callback. Let's see what's going on there. Okay, so writes 155 bytes. And is self valid? It looks good. Okay, oh, hold on. It threw an exception trying to grab that mutex. I bet it's already locked. Whoa. Error-driven development. That's right. You start off with errors and you fix them. Yes. It's re-entering. That's what it's doing. That's easy to fix. We will go to mutex and we will make it recursive. So it's now re-entrant. You have to make that an any though to make that work. Okay, running again. Ooh. It's doing something. Didn't crash. It's also not fetching anything. Let's see what it did. Configure, connect, connected. Starting, it read, it queued 62 bytes. It tried to write 155. It tried to read 5. I should probably print out how many were available. I wonder if it's actually really sending something out. Writing code which doesn't have errors is honestly far more disturbing. Oh yeah, I'm definitely, when it works the first time, I'm like, what the heck did I do wrong? Shouldn't work the first time. Write callback. It's supposed to be sending data to the network, but I wonder if it's not. Would it be interesting to see what the data looks like? Let's see. What does the data look like? View. Windows. Memory. Make it so hard to get to sometimes, so it's buff. Ah. It looks like a bunch of binary stuff to me. I wonder if it's not sending some kind of prefix to start the TLS connection. I wonder if that's what it is. Like, are we supposed to write some kind of text to the, like a text string first to say, hey, we're starting TLS? Because I think it is sending. Let's see it. Let's watch it send here. Stepping through all that, so it sends the message to the adaptd, send message to the network connection. So it's going to go to that queue. It will try to write here. Oh, wait. It's never getting there? Oh, it did. Okay. Weird. Okay, so there's the 155 characters. It tries to send it to the socket, which is not... Okay, it sent all 155 bytes. It sent. All right. I'm guessing that there's some kind of thing that you have to do with HTTPS to start TLS or something. Let's look it up. Actually, what if, isn't there a RFC for HTTPS? Yeah, maybe there's something that I just need to do to get it started. Client connection initiation. TLS client hello? Client hello? Hopefully it's something simple. Okay, I try not to do research on stream, but I'm hoping this is just something simple. Maybe it's not. How come it doesn't define that? What's the TLS hello? Let's just search for that. Oh, why did my clipboard not work? It's, go back. It's hello something. Client hello. Let's just do another new tab, shall we? All right, Jesse, thanks for coming by and thanks for the raid. We'll figure this out. MK. Maybe we'll read something here. See, I thought that the libtls would do this for me, but maybe it doesn't. At least this first part here. Anyway, what is it doing after it sends that? It's actually, it's trying to read 62 bytes over and over again? No, it's trying to write 62 bytes over and over again. How would we know whether or not libtls does the hello? I'm not sure. I don't know. That's why I was looking at those 155 bytes, right? And I don't know what the hello looks like. But this looks to me like it might be the hello because it's got the wikipedia.org, the server name in it. This is basically what it's sending, these raw bytes, which look pretty binary except for it's got the host name in there. I don't know if this is the client hello or not. I was hoping it was. It's sending it. Can I run Wireshark without revealing personal info? Maybe I'll run it off stream. And I will start capturing, although this is going to be a lot of stuff from my stream, but let me give it a try. So I'm going to restart Wireshark and then go. Stop Wireshark. And then I need to look up what's the IP address of wikipedia.org. Can I do that here? Okay, 198.35.26.96. So let me just type that in. I just want to make sure no personal info gets leaked out. I think we're good because it's showing just my behind the net addresses. Oh, we are sending the client hello. Look at that. And it's sending us an ACK. Okay, it did send us the server hello. How come that's not reflected in this message here? So 62 bytes. That's probably, let's see. Where does it say length? I guess it would be here. 155. Oh yeah, how come it's saying 60? No, okay, here it is. It's 62 bytes that we're sending. That's our HTTP request, right? And it's translating that into 155 bytes, which is the client hello. Okay, so it sent the client hello. And then later we tried to write 62 bytes more. Actually, why is this happening? Don't know. But anyway, we got the server did respond with the server hello. And there was a certificate exchange. It actually looked like the exchange was done. So it's the TLS is doing the correct thing. I'm not getting the data back out. I'm actually wondering why it's trying to send the 62 bytes over and over again. Maybe that's the clue. So where do I do that TLS write? Send buffer, okay. See, I'm supposed to erase it after it's sent. What did TLS write return? Actually, it's not returning anything. Oh, it's always returning want poll in. Hold on. Where do I print that from? Okay, let me prefix this with that so it's a little bit easier to read. And then there too. Then go again. Okay. Read return want poll in. Well, the top one should say write returned. Oh yeah, you're right, huh? I did that. I'm dumb. I did that twice now. I guess I'm pretty bad at doing copy paste today. Okay, read return want poll in. Write returned want poll in. The data from the underlying connection is not coming back out. That's the problem, I think. Because if it did, this data received callback would have been called received secure data, and that's never called. Let's put a breakpoint in this class, which does the data received callback. Where was that? Oh, it was all down here, wasn't it? No? Oh, it's passed in. What did maybe I passed in the wrong thing. Oh, I passed in the wrong thing. It's delivering data straight up to Rover. Yeah, that's not good. So let me think about this. We want our function to go here, not theirs. So let's see how do I do this? How did I think I was doing it before? Oh yeah, this is a null. Right. It's sort of a design flaw. I have these sets, but the way I have the connect stuff to avoid a chicken and the egg problem, I pass them in directly. And they're sent to the process function directly. So these sets aren't actually doing anything. So this has to be moved. This has got to move to where the connect is done. Down here. They have to be passed in there. So somehow I got to set these up. These have to go back into the connection decorator. Okay, I think I'll just make them methods. So that would be, let's plug them in. Can you correct connect decorator not yield them? Yeah, sort of, I think that's what I'm gonna do. So it's gonna just pass them in directly here. I just need to modify the captures a little bit. I apologize for my Lambda functions being inline, looking ugly. So it's got to get to this guy. Let me do it an ugly way and I'll do it clean in a bit. So let's get connection decorator raw. Get inaccessible. Why is it inaccessible? Oh, yeah. Okay. So I have to make these public methods. This will clean up my lambdas a little bit. So they'll be public methods. These public methods. So this method is called when secure data comes in from the TLS layer. And it's going to have the same signature, so the same comments for these delegates. So this documentation I'm going to totally rip off and paste here. And it'll be secure data received. Received. There we go. And then this method is called when the underlying, well, when the connection, when the, actually we're calling it the upper layer, but it's really the lower layer. Upper layer connection is broken. Connection broken, let's just call it that. And I don't need that flag, so I'm not going to pass it. Oh, wait a minute, I did need it. Okay, so let's copy it. I was only doing that to be polite. Because this belongs to our web client, and it might care if it was a graceful close or not. It shouldn't because it's HTTP, but later if I use TLS with other protocols that might support half-open connections. Actually, I don't think that you can use half-open connections with TLS because there's handshaking, right? So probably don't need that, but anyway. Now we have formal methods, and I can just reduce this to say connection decorator raw secure data received. Don't know why it really gets screwed up with the indentation though. Yay is right. Hopefully this works. Connection broken. I need to go back and do a lot of refactoring of this code because until I can read it and understand what's going on, I know it's in need of refactoring. But today it was all about playing around with TLS. So I didn't really expect it to work the first time. Did I run it and just be optimistic that it gives me the right thing? No, I shouldn't have done that. Okay. Okay, it's still not doing the right thing. So, is this never getting called? This should be called when we get data. No, we got data back. We got 4K of data. Is that how much data that it really sends us? Oh yeah, a lot of data. That adds up. Quite a bit of data. So yeah, we got a whole 4K of data. So where did it go? Okay, it should have printed that. How come I didn't see that? Do you see a received secure data anywhere there? I don't. Oh, there it was. It wasn't for a while though. Am I like polling needlessly? I think I have some problem with it's waking up too soon. The reason why I'm wrapping the connection decorator call in a lambda still, I think it's because I don't like to use bind. So this expects a function object. So I can make a function object by using bind. But I really don't like to do that. But maybe I can. Just to get some exercise using bind. I need to look it up in the manual though. Unless you happen to know off the top of your head how to do it. It has something to do with bind. And I have to use the forwarding placeholders, right? Yeah, it's just like standard placeholders 1. So it would be something like this. Standard bind. And it's TLS connection decorator secure data received. And then this guy. And then standard placeholders 1 underscore 1. And that probably needs an address. So that's the way to do it with a bind. Yeah, C++ isn't for everyone. It's definitely grody, or gross, or whatever you want to say. So I don't know. What do you think looks better, a bind or a lambda which just does a forward? This technically is supposed to be more efficient because it's supposed to give you a perfect forwarder. But I don't like this gunk. And sometimes a lot of people just do using standard placeholders so they can just say that. But I don't know if I'm comfortable with that. I don't know, it might look a little bit better if I do this. We'll leave it in there just to be an example. How about that? Like I say, here's an example of how you make a forwarding bind with a forwarder. There's a bind in JavaScript too, right? Can't remember the syntax, but it's the same concept. You're taking an object and a method and binding them together to make a callable object. Okay, so we are getting the data back. What? Pull in, worker wake up, write, read. Okay, what am I doing with that data when it comes in? I'm putting in receive buffer secure. And where do I actually read that back out? Oh, this is all old crap. You move this. Right, it should get back into here. Let's put something in here that says how much is available. I'll be careful, I'll put it there. Read is available. And then we'll put that here. Maybe while I'm here, I'll try to figure out why it's waking up so much. I think it's because when write gets blocked by this read, where is it? Not there. Where is it? Here's the write. When it returns, we can't write anymore. It's still going to wake up because this is still true, right? The send buffer. My worker needs to sleep more. Yeah, it's waking up because it's still trying to send those 62 bytes, and it's like, well, I can't send them because I'm waiting for data to come back. So should probably have a flag for that, right? Actually, that maybe goes along with the try write. So try write should be here. It's a little bit different from the try read, because try read will be read even though you haven't received anything yet. And that's because the TLS, I expect it to possibly buffer input. Do I expect it to buffer output though? No, we won't. It won't buffer. We won't need to call it to flush buffers. So maybe I should name that a little bit different. How about write? Write permitted. Or I could reverse the logic. Can write. That's a good one. Whoa. What happened? What happened? Okay. Can write. By the way, I really appreciate the feedback. I'm bad with names sometimes. So we know we cannot write if we get here. Now, when do we know that we possibly could write again? It's if we actually succeed in reading, right? That would be when the read callback happens up here. Read callback. If data is actually available, right? Oh, which means it needs to be part of our object state itself. So I need to promote that guy. So he is now a variable, a piece of state. The Mater, are you the one that first used that off by one joke? Because I've seen it from multiple streams. Is it just making the rounds? Are you the author of that? It's a good joke. I wish I could remember who said it first. Okay, here's my state. Actually, the state is at the end of these private properties. Yeah, here we go. Open, can write. This flag indicates whether or not we should attempt to write data to the TLS layer. It can be, or it's cleared if TLS write returns the special code, right? I'm trying to find it in the header, but it's like poll in. Yeah. And set again when the read callback is able to deliver more data to the TLS layer. And need to wrap this. And multi-threading, yes. Multi-threading. I'm living dangerously. Okay, so we can write again if the read callback gives more data to TLS. And we only try to write if we can write, and we can't write anymore if poll in is returned, yes. And then we should modify the wake up thing. So it's these two conditions have to be simultaneously true. It's not empty and we can write. Let's try this out. I'm eternally optimistic and I think that it'll just work, but I'll probably be wrong. Let's see what goes. Oh, that's interesting. So what did it do? We got an atom nuke. That's funny. Okay, connected. It wrote the 155 bytes. No data available. Okay, the read wanted to pull in. The worker woke up, tried to write those 62 that were queued, right? We received the secured data. Woke up, we read, received more secure data. Here, the read callback returned 4,096 bytes. Then TLS read returned -1. Oh, was it a Martin Fowler joke? There we go. So it's Leon Bambrick. It's a good joke though. Okay, so we're getting there. We received the secure data back. It's just TLS read doesn't like it. Returning -1. At what point did we read? Okay, we read right here. While we were reading, we received secured data. The callback happened and the data was available. This I should print how many I received, right? Let's say more bytes total. And then we will say that and then plus what we already had. And I should protect that, shouldn't I? Okay. That time we received only 1460 bytes. TLS is returning -1 though. Oh, it's this, and then there was nothing in there before, so it's that we've received total. The previous run, it was 4K. This time we only got 1.4K. Yeah, but those same bytes are now available to the callback. For some reason it's returning -1 though. Actually, it might be, we might have received it. I wonder, okay, I wonder if there's a way we can get like information out of TLS. Maybe in their examples they have something where we can get more information out. Okay, they don't have it there. -1 is usually an error, not end of data. So, where is read? Here's read. -1 on error. Now, let's see. Oh, TLS error. Oh, it looks like we can call a function called TLS error. So let's try that. Okay, TLS error. Okay, let's try this. So TLS impl a get, and we get back out a string, right? So TLS error message. TLS error says that, do the right thing here. Is that safe? Yeah, because it's an argument. Okay. Let's see what we get. Handshake failed. Connect CR server hello wrong version number. Interesting. Yeah, it's a C string because libtls is C. Huh. Wrong version number. Why would we get that? Maybe the data is corrupted. Here we received 2 chunks of data that they added up. Are we getting the same error every time? Wrong version number. Another problem is I'm having to hit Control C, which I shouldn't have to hit. It should just, the error should percolate up. Why am I getting a wrong version number? This said version there. Actually, here's another useful thing about Wireshark is if we can inspect the raw bytes to see like where things are. So this is the stuff we should get back, and it looks like the version number is in the 2nd and 3rd bytes. So if we wanted to, we could print that out. Yeah, that 16 byte is the content type, and the version number is the next 2 bytes. Oh, did you find me a link? You're so awesome. What is the answer? I should enable support for v3. So Wikipedia does say 1.2. Maybe I need to enable 1.2? What did our client hello do? Oh, our client hello did 1.0. Oh, that might be it. Maybe I have to enable 1.2. Because we shouldn't be trying to do 1.0, right? That's probably it. So that's probably part of the configure. Why do I have 2 different windows? I don't know. Pull that in there, please. There we go. Yes, so does that mean I have to retry? Actually, I would like to try with 1.2 first. It's probably all in that configuration stuff, right? The example didn't really do much. So, like, I don't see it setting a version number. Sort of a crappy example, isn't it? It just says configure. The only thing it does for the configure is it says, I guess that's saying don't verify the certificate or the name of the server. I actually don't think we should be doing that. We should be verifying it, right? Okay, what does configure? Configure say anything to help us out? Verify conversion? No. Set protocols. Load file. I've heard this before. What is stapling? I don't know. Set protocols. Maybe this is it. Ah, here we go. Which versions may be used? So what is the default? Weird. If the default is what they set, if you don't set it, shouldn't it be 1.2? But ours did 1.0 for some reason. 1.0. Well, let's try that. Let's try that now. Configure. I don't know about these guys. Well, we'll leave them in there for now. We'll say, I don't know about this, but it was in the example. Let's bound this. because I'm suspicious of that. I'll probably remove it. So this was config set protocols. TLS config get, and they say you can do, let's just do the protocols default and see what we get. This is from the source code of libtls. Might be helpful. Oh, you found so helpful today. Yeah, just wondering what it does if you don't call TLS set protocols. Yeah, this is for if it comes in as a string, right? Like command line. That actually might be useful later. Let me bookmark that. Because we might want to, in our code, be a bit more professional and allow it to be configured from the command line or config file, right? So consider using later when configuring TLS options. All right, so we're gonna try this. Still wrong version number, but I want to do that while I am capturing traffic to see what version we're sending. So I already have this filter going up. If I just hit new again and then hit go, there we go. Stop. Oh, awesome. You can feel free to laugh at me if I make mistakes. Look, it's still trying to negotiate with 1.0. And the server's saying, hello, I want 1.2. It's interesting. The handshake continues, like, I guess it's passing a certificate. Yeah, it's passing, the server's passing us its certificate. And I guess we're saying no thanks and we're closing. Anyway. It's still setting 1.0. What am I doing wrong? It's 1.2, so yeah. Well, the initial hello should be when we connect, right? Let me look this up. Again, why did I open that as a new tab? Let's look. Wrong version number. I'm sure I'm doing some noob mistake. See, this is all higher level stuff. Yeah, not gonna work. How about we say libtls? How about just libtls wrong version number? Wonder if this is the same thing you were posting before, or I don't have it anymore. Again, this is all higher level stuff. Anyway, what does this actually do? It just sets it there and returns there. Oh, that's interesting. Huh. It's actually pretty readable. looks like when I call set protocols, I'm passing a UN32, which is flags for different protocols. Okay, are there other flags I need to be worried about? Yeah, so it's setting it to 1.2, or it should be setting it to 1.2. I just expected that if we set it before we do configure, it would be the right thing. Yeah, anyway, this code is pretty readable. It actually told us what routine it was in, didn't it? I could probably search for that wrong version number. I wonder if the data is just corrupt. We can inspect that pretty easily in our code, right? So secure data. We can just look at it here. Don't need any of this stuff. Okay, here we go. The data. Data. Well, there are the bytes there. Those are what we saw before in here. 16 hex 3 3. 16 3 3. Okay, but maybe in the read callback it's not correct. Oh, you know what? I know what I did. Okay, this is stupid. I returned the amount, but I never put it in their buffer. Okay. We have to actually copy the data into their buffer. Otherwise we didn't give it to them. Yeah. Oof, that's right. So, copy the data, yes. And I never actually removed it out, did I? I totally missed all that. So, receive. How come it's not letting me see that? Dot data. And then the size is amount. And then we need to remove that out of the front. Well, if amount is equal to that dot size, it's clear. Else, erase from the beginning to the beginning plus the amount. All right. Yeah, it would help if we actually gave TLS the data. Okay, I forgot to Control C that guy. Ooh, it got much further. Did it actually give us the document? It's all scrambled. Oh, that's two printfs competing with each other, I think, actually. It actually did a fair amount of exchange, though. Huh. Did I actually get a web page back? I didn't actually get a web page back. Yeah, sync the printf. The printf is really just a hack right now. I should build in like a real diagnostic callback like I have in my other classes. I kind of want to see this in Wireshark though. Let's repeat. Repeat. Go. Okay. It actually transmitted quite a bit of data. Certificate status, cipher exchange, application data. What's this encrypted alert mean? I don't know. Quite a bit of data went across though. 80K? But it never delivered it up. I wonder if, do we never deliver it to the upper layer? Yeah, it's supposed to print it out to the standard output. Like it does when you do HTTP, right? It's supposed to just print the headers and the body. So if I got rid of all the printfs, we wouldn't see all this stuff, but we wouldn't see anything. Maybe I did something dumb in the read as well. What did I do with the actual data we read? Okay, I called it. But do I not store this? This is what I want to see, right here. Let's clear all the other breakpoints except for abort. I like to keep abort around. Right there. Oh, I am getting data back. Oh, look at that. There's the response. Is it just not set? Oh, that's it. It's not set. It is another dumb mistake. Yeah, right. Yeah, it's the same pattern. We sent it in here, but I didn't store it because I'm dumb. Okay, so it's connection decorator data received. Oh, it's private. So I just need to pass it up here. Yeah, private, because I made it a class, so disconnect with it. One problem I have is I have two functions at different layers that are both called connect, so I'm like setting myself up to be confused. Okay, but it has the same semantics as this connect, which takes its delegates passed in. So we'll copy that documentation to here, and we just store them. So data received delegate, and broken delegate. That's actually probably why I had to hit Control C, because the broken delegate's never called. And then this set stuff shouldn't do anything. Where was it? Down here. I need to remove that from the API, I think. Because that's twice now that it screwed me up today. I shoot myself in the foot all the time. That's what you guys are here for, is to tell me. And then I will hopefully learn from my mistakes. Oh, look. I actually think I got something out. It just got scrambled in there. Our end, other end broke. Breaking our end. Okay, where's the data though? Do I still have my breakpoints? No. Okay. How come it's not being called? Yeah, transaction receipt. It got here's the response. HTTP 1.1 200 okay. The date. Okay. It accepted it. Is it a complete response? It's still trying to parse the body. It received more data. I should have put a breakpoint in there. Now it's still parsing the body. Okay. More data. Let's put a breakpoint here. Still parsing the body. I guess it's a chunked body. Oh, what? Oh, the connection was broken. Why? Oh, is the connection broken by their end first? No, we break our end first. So we should have completed the transaction. What does Rover say? Is it broken? Let's see. I don't need this memory window anymore. And oh, it thinks the connection got broken. It it oh, actually I can look at the response and see what's there. Um, transaction. It's got a response in it. It got an OK. It was still reading the body for some reason. It's got a bunch of headers in it. They all look kosher, I guess. Why is the server MW1246 Equiad WMNet? Weird. What is that? Is that like a load balancing server from Wikipedia? I don't know. So, okay. Let me think about this. Let's search for where that state broken actually happens. No. HTTP. Broken. Here. Okay, it was in progress and now it's broken because the connection got broken. I wonder if I could look into the connection state, connection object. No, I can't. All right. It probably has something to do with some of the parsing, parse response. I thought I had fixed this the other day where it should get, well, maybe the connection close is assumed. Let's see where it gets to. It's either going to be, there's got a content length, or it's transfer encoded, or it's connection closed. So let's see which one it is. Okay, it does have a content length. What is the content length? 757550. And what's the bytes available for the body? 146. Okay, the connection is breaking before it actually receives all of the data. Oh, I think I know why. The connection is breaking, but TLS hasn't received all the data so far. I mean, it hasn't processed all the data so far. So it's received 74K, and it hasn't read it all back yet. But we're passing through the fact that the connection is broken, and we're not processing the rest of the data. Okay. We're almost there, I think. It's not a timeout. What happens It's kind of hard to explain. The data comes back out from TLS read, right? But we're only allowing it, well, we're trying to read 64K at a time, but it's only, if I can show it here. Data is coming in, but it's not reading all of it. So like by the time the server has given us all the data and it closes its end, and we've received the response, but we haven't parsed it all in the TLS read yet. And we're passing through that broken delegate right away. This connection broken, we're calling it right away even if we have data. So I could probably see it right here. If I go to here and I look at our state, receive buffer secure. So we still have 66,980 bytes yet to decrypt. We haven't decrypted it all yet. Yeah, before we call a broken delegate, we want to like basically continue to decrypt stuff. What's this? I don't know what this is. Huh. I got some notification on my computer I've never seen before. Anyway. Yeah, we need to hold off from doing that until we've processed all the data, I think. Let's do this. So we'll do, we already do this, we'll already do that. So we'll move this code. I'll move that, which means I really don't need this graceful anymore. Connection broken. We don't need that. Still have that in my clipboard, right? So we set the open to false. In our worker here, I think what we'll do is after we've read the last, yeah, we already have that Boolean open. So what we'll do is when we've received all the data and sent it all back out, that's just the callback in our worker thread here, where we've sent it all back out. If we have no more data, then we will close. But we have to be careful though, if it terminates early. Actually, I think TLS will just consume the rest of the data, right? So let's just put the check in here. Where is it? Where do we remove it? Oh, it's in the callback, isn't it? Okay, we remove it there, and then we'll check it here when it comes back out here after we've done this. So we'll say if data receive buffer secure empty and not open, which means we have to continue looping even if it's not open, right? Yeah. Either that or I need another flag. I know what I'll do. I'll remove that condition. I'll finish the code I was doing here. So if it's empty and not open, we will call a broken delegate, and we just need to make sure we don't keep trying to read and write a broken connection. Yeah, we don't need, so it's this and open. This we want to do even if it's not open anymore because it's really reading from a buffer, not directly. But in our callbacks, we need to be careful as well. Oh, we already are. What does the right do? Okay, the right doesn't. The right needs a guard though. If open, self open. Is it not self open? Yeah, it does. Oh, it's probably because I did that, right? Yeah. When you're inside of a lambda, if you like do something like that, it'll screw up in IntelliSense. Actually, you know what I want to do? I want to put that back in here when if the connection breaks when there's no data to be decoded. Because I can see that happening. If receive buffer secure is empty, because otherwise we'll never get into this code at all here, because it'll never read anything because there's nothing to read. Oh, look at that. It worked. Although it didn't, it destroyed it, but it didn't exit all the way out. So that's one bug left to fix. We got actual secure web page downloaded. Yay. There's a lot of stuff Wikipedia sends you. Wow. Okay then. Okay, here are the headers. Okay. Probably shouldn't show it too closely because I think it's got some personal info in it. So this end part is fine. It's just JavaScript. Okay, it gets stuck. Let's find out why it's getting stuck. So I'll hit go. And where's the output window? Here it is. So it's received everything and it's just actually destroyed the TLS wrapper, but for some reason it's still waiting on something. I hit break, where is it? Threads. What's my main thread doing? Okay, it's waiting for the connection decorator to stop. Why is it not stopping? It's waiting. Is it still in wait? Weird. Which worker is this? Oh, this is the client's worker. That is just waiting too. Why is this stuck? Stop worker is oh, hold on. I think I know why. I never signaled. That's wake condition notify all. I bet you that was it. Yeah, look at that. Awesomeness. Now I need to test it with web servers that are actually broken to test my other failure points, right? It's going to be hard because normally I would use test-driven development, and so I would mock the server, but that would require that I have a server that speaks TLS. I guess eventually I'll have that and I can come back and have a real server with TLS be a mock for the client. I think for now we'll just check in our work and call it a day. Yeah, I am 45 minutes over, but I'm happy because I got this to work. Okay, what did I change? Just Rover, right? So the TLS wrapper lives in Rover now. We'll probably spend some time next stream and maybe take 1 or 2 streams to kind of clean this up and move this TLX connection decorator out to its own little library that we can reuse. Okay, so that's the big changes. We filled in the TLS connect decorator. So fully implement TLS decorator. and bring in SSL and crypto dependencies. This I consider a bug in the CMake, actually, and its dependency. The fact that I had to bring in TLS's dependencies like that is sort of, I think, a bug. I should just have to say that, and then if it depends on these, that's fine. It should handle that in its CMake. But, you know, I can live with it. It's only 2 things. Commit that guy. Alright. So yeah, as long as you guys promise to use your powers only for good, all this code is available in GitHub. There's like a link below to the top level repo. And just to note that when you clone that, you'll get only the outer function, the outer directory. And then in either this main or this get XML, the get is if you don't have an account in GitHub. Main is if you do. But either way, it kind of lists all the sub repos, and I made a tool called Mugget that I use to automate the process of cloning and updating them. But you can just look at what you want. They're all in GitHub, and it's all MIT license, so it's all for fun, and if it's useful for you guys, that's good too. So let's see. We experimented with TLS. I actually sort of didn't expect it to work in one stream, but I was pleasantly surprised we got it to work. So next stream I'll probably clean it up and wrap up the TLS into a library that we can reuse. I want to be able to reuse it with other protocols, like SSH is shell over, or login shell over TLS as well. So it'd be nice if we could make TLS a more generic, or the library that I use to wrap TLS more generic, so we can use it for other things other than HTTP. So that'll involve a little bit of a change, because right now, this decorator is for HTTP's connection. I need to actually have it decorate network connection, the more generic class. But the mechanics of doing the callbacks and the connect and all that should stay the same. We'll just be cleaning it up and moving things around. So, I think I'm going to wrap it up for today. We will go host someone else. Wish I could host Adam, but he is not streaming on Thursdays. There's actually no one streaming now that I know, which is really weird. Anybody you guys know streaming right now that we could go host? I guess I could browse and look at programming community and see who's going now. Someone I don't know. Yeah, I wonder why. Thursday seems to be like a slow day. Oh, Honest Dan Games is going. See what he's doing. I think we'll host Honest Dan. I've watched him before. He's working on game dev on the web, so he's using Vue.js. Actually, it says he's learning the basics of it while developing his own personal website. So we'll go say hi to him. So thank you guys very much. I'll see you soon.